Hi, in this video I'm going to talk about linear combinations of vectors. Now a vector v in a Euclidean space Rn can be represented as a linear combination of vectors u1 up to un, which are also in our vector space, such that this applies. So here alpha 1, alpha 2, etc. are just scalars, so they'll be real numbers. So if we have alpha 1 times the vector u1 plus alpha 2 times the vector u2, and so on and so forth, up to alpha n multiplied by the vector un, this is equal to our vector v. So this is known, the left hand side here is a linear combination of the vectors u1 up to un. So here's a simple example. So here we've got two vectors, and if I multiply the first vector by 2, and then add on the second vector, we have 2, 0, 7. So we can say that this vector 2, 0, 7 is a linear combination of these two vectors. So let's have a look at an example. So here we have the vector 0, 9 and 11, and we're going to represent it as a linear combination of these three vectors here. So what we have is that we have this linear system. So we have some number alpha 1 times our first vector plus some number alpha 2 times our second vector, and another number alpha 3 times the third vector, and we want to make this equal to our vector 0, 9 and 11. So alpha 1, alpha 2 and alpha 3 are unknown, and we have a linear system. So we need to solve this linear system for those unknowns. Okay, so I'm going to use Gaussian elimination. If you're not quite sure what Gaussian elimination is, I suggest you go back and watch my video on it. So here we have the augmented matrix. So if we are just going to go back a slide, we have our three vectors here. These form the three columns of the augmented matrix, or the first three columns. Then we have our partition, and then on the right hand side of the partition we have our vector on the right hand side. Okay. So I'm going to row reduce this to reduce row echelon form. Okay, so to reduce 2 and 3, I'm going to subtract 2 times row 1 from row 2, and 3 multiplied by row 1 from row 3. Okay, so now my pivot is minus 5, so I'm going to multiply that by minus 1/5. And this has the effect of reducing that pivot to 1. And then if I want to reduce the 2 above, I subtract 2 lots of row 2 from row 1. And if I want to reduce the minus 3 below, I add 3 lots of row 2 to row 3. And the next step is I'm going to multiply the row 3 by 5/7 to reduce the 7/5 to 1. And I'm going to perform 2 row operations to reduce the 2 non-zero elements above my 1. So I end up with the identity matrix on the left hand side of the partition and some values on the right hand side. So this is now in reduced row echelon form. Okay, so what this means is alpha 1 is equal to 2, alpha 2 is equal to -1, and alpha 3 is equal to 4. So therefore I can write my vector 0, 9, 11 as a linear combination of those three vectors. So here we have alpha 1 is 2, alpha 2 is -1, and alpha 3 was 4.